Okay, so in this particular video series, we're going to be dipping our fingers back into the world of financial mathematics and seeing how we can apply the knowledge that we've learnt from sequences and series, particularly geometric series and sequences, into the world of finance. Now, for those of you who aren't in my class and that do watch these videos to have a little bit of a hand with what they're doing, my advice to you is to read up and study arithmetic series and sequences as well as geometric series and sequences before attempting other videos that come later on in this series. But first off, we're going to sort of just do a little bit of a recap before we get into anything involving that sort of stuff, and that recap is going to be on simple interest. Okay, you would have seen this before if you were in the advanced course way back in year 10. Okay, and it's always handy to sort of use this idea as a stepping stone to sort of dive back into terminology and all of that sort of stuff before we carry on. Okay, so everything else that we do from here on will focus more around compound interest, okay, because that has more applications in everyday life, but simple interest is nice for us to help get the point across in everything that we're doing. Okay, so let's start having a look at the simple interest formula here. Okay, so first off, it's in the form of I equals PRN. I here refers to our interest that we gain. P here, you've probably seen this before, it's often referred to as the principal amount, okay, or our present value that we sort of put into the account. The R here is our interest rate, okay, so for example, we could invest something at 5% per annum, and N here is the number of time periods that our money is sort of in the bank account gaining interest. So that's sort of how we do this. Now, the important thing is here, this formula only calculates the interest generated off of an investment. It doesn't calculate our final amount at the end of the time period that's in our account. To work that out, though, it's simple. It's just the money that we started off with, our principal, plus the interest that we gained over the entire time period. Another thing to think about with simple interest, it's a little bit different to compound interest. We will talk about compound interest in the next couple of videos. It doesn't grow an exponential rate, okay? So the value of our investment over time only grows what's known as a constant rate, okay? So it goes up by the same amount each year, okay? So our principal just pays a certain amount of interest, and that's it. It's like we can just walk away from the bank and stick that interest into our pocket. Okay, so it's pretty straightforward. I reckon we just dive into a question just to get us started off. Okay, so let's look at this question here. It's got two parts to it, both sort of assessing different skills, but using the same simple interest formula. It says a principal P is invested at 6% per annum simple interest. Now, the key thing is here that it does say simple interest. We're not using compound interest here. We will get to that. All right, if we look at part I, this is the first part of the question. They're both separate parts, okay, but they do use this same 6% simple interest in regards to this. Okay, so first things first, when we look at part I, it says if the principal is equal to $3,000, how much money will there be after 7 years? To do this, first things first, we just need to set ourselves up with the formula. Okay, so our formula, remember, is I equals P N, where P is the principal, and I like to come over here just to the side and sort of write out what my principal value is. Okay, my principal amount is 3,000. That's the amount that we're starting off with. Okay, our interest rate is 6% per annum. Now, what per annum means is it means per year. What I really want you to understand is that we're not going to plug this 6% straight into the formula, okay? What we are going to do is we're going to convert it to a decimal. We always convert this to a decimal, all right? 6% is 6 divided by 100, which will give you 0.06 as a decimal. The final thing that you need to identify is how many time periods in there. Well, it has 6% per annum. The number of time periods that it is in there for is 7. So in this particular case, N equals 7. Then it's just a matter of plugging in all of your values into the formula. So I is equal to P, which is 3,000, times your interest rate, 0.06, times the number of time periods that is in there, which is equal to 7. What you then do is you just plug that into your calculator and you should come up with the value of $1,260. Now, what a lot of people might forget is that this is only the value of the interest. This is asking you, in this question, is how much money in total is in the account at the end of the 7 years. To find that, okay, The total amount is simply just the amount is equal to the principal that you started with plus the interest that you gained. Okay, which is equal to 3,000 for your principal, okay, plus your interest, which we've just found, which is 1,260. So the total amount at the end of the time period that the money is in the account for is $4,260. Okay, so that's the answer to part 1. So now let's have a little bit of a look at part 2. Okay, so in the second part of this question, it says, find the principal if the total amount at the end of 5 years is $6,500. Okay, so the key thing to highlight there is that the end amount after 5 years is $6,500, okay, and it's asking for the total amount. It's a little bit different to then just starting off with the simple interest formula, as we have to sort of work backwards from the total amount. Okay, this is why I sort of left this question on the page, just to sort of highlight this particular formula here. Okay, so for part II, we know that our final amount is equal to the principal plus our interest. Okay, what we can do is we can try and reduce the number of variables that we're working with by using this simple interest formula. We know our interest is equal to this particular formula here. So what we're going to do is we're going to rewrite our formula for our amount. I'm just going to rewrite it as A to be shorthand. It's equal to our principal, I'll label it as P, plus our interest. Well, we know our interest is equal to PRN. Oh, sorry, that's meant to be a P, but we'll just put that beside each other. Okay, so our total amount that we have is equal to P plus PRN. All right, now what we can do is we can start plugging in values once we've identified them. Okay, so we know our A is equal to 6,500. Our amount at the end is in there for a period of 5 years, so N is equal to 5. We don't know what our principal is because that's what we're trying to find, and our interest rate is the same as last question. Okay, so we know that is equal to 0.06. So now what we do is we're just going to substitute everything in and begin working out to solve our equation for P. Okay, so after substituting everything in, we get 6,500 is equal to P plus P times our interest rate, 0.06, times our number of time periods. Okay. What you might notice here is that there's a common factor on both terms, which might make it a little bit easier for you to see. So I'm going to factorise out this P just so you can see what's going on. Alright, I'll end up with P outside of 1, because I'll be left with a common factor of 1 there, plus 0.06 times 5, which is 0.3. Tidying up this bracket here, I end up with 6,500 is equal to 1 plus 0.3, well that is just 1.3 times P. Now, I just need to isolate P by itself to solve the equation. So I know P is equal to 6,500 over 1.3. Simplifying that down, we end up with $5,000. So, our principal amount that we're starting off with in this particular account is $5,000. Slightly different to what we did before, but again, using that same strategy, just knowing how to manipulate all of the formulas, okay? So just remember, when you're doing simple interest, you need to know I equals PRN, and this particular formula here, amount is equal to the principal plus interest, and you'll be able to answer most questions that sort of pop up in this sort of domain, okay? So the next couple of videos, we'll look at how compound interest is related to geometric progressions, and we'll start to dive into some harder things like superannuation and loan repayments, okay? Thank you very much.